Hi Ramblers! In this video we're going to learn to work with proofs where we're not given a diagram. The book calls it the case of the missing diagram. And as corny as it is, it's important because as you get into more advanced math classes, you're usually not going to be given a diagram. So we're going to look at three different types of cases. One where the givens are really presented to you directly and what to prove is presented to you directly. The second is in a conditional statement. You're given a conditional statement in if-then form and you've got to prove it. And so we'll look at how do you know what you've been given and how do you know what to prove. And then the last one is maybe the most difficult of all, and it's a declarative sentence. So I hope this video helps and good luck. Okay, we're going to look at three examples of proofs where we're not given a diagram. We'll start with the easiest one first. In this type of proof, the given and prove statements are told to us directly. So it's our job to draw a diagram and then restate the given and prove kind of in a consistent manner through all these types of proofs. So I always put the diagram over on the right, the given and prove on the left, and we start with the diagram. So I want to see an isosceles triangle with the median drawn to the base. So my diagram looks like this. It's an isosceles triangle, and I have AD is going to end up being a median. So let's take a look at the caption. I'm sorry, at the givens. Triangle ABC is isosceles with base BC, and AD is a median to BC. Now that definitely restates what was given, and you'll notice that I always like to start off with triangle ABC, and I'd appreciate it if you would do that as well. It makes grading much easier if we all have things labeled the same way. Now, our next job is to look at what we're trying to prove. We're trying to show that AD is the perpendicular bisector of BC. So, in these examples, we're not so much concerned with how to do the proof yet. That will come. We really want to just focus on setting up everything correctly. Notice how I drew my diagram first, and then I took the given and the prove and rewrote them in terms of the diagram. So using the vertices and the lettering of the diagram in my given and prove statement. I want to make sure that you do that. Okay, let's take a look at the next example. The second example is a little bit more complex because what is given and what we need to prove isn't quite as obvious. So let's take the statement, if the base of an isosceles triangle is extended in both directions, then the exterior angles formed are congruent. The givens are going to be found in the if portion, or the hypothesis of this statement. What we have to prove is found in the conclusion portion, or the then portion. But once again, we lay out our givens and our prove over on the left, and I want you to put our diagram over on the right. And we start with the diagram. So I know that I need an isosceles triangle whose base has been extended in both directions. Now I'm going to write my givens. They're going to be taken from the if portion of this statement, and they're going to be written in terms of the lettering and the notation of the diagram I drew. So I know from the if that ABC is isosceles and the base is BC. If the diagram shows that the base has been extended, in my givens I merely need to identify BC as the base. So my prove is going to come from the then, which is going to be that angle ABD is congruent to ACE. Notice that we don't have any sentences in our given or our prove. We are just taking the given sentence or the given statement and breaking it down to a proof just like we would have seen in the exercises in some of the earlier chapters. Okay, once again, we're not concerned right now with how to prove this. We're just working on the setup. So now that you've seen that, let's move on. The final example we'll look at is probably the most difficult of all. The prior example was a conditional sentence. We've worked with those in the past. This last one is a declarative. And the trick is using an analysis tool that you learned in grade school. You may remember the two parts of a sentence were the subject and the predicate. And the givens are going to come from the subject, and what we have to prove comes from the predicate. Now you may remember that the subject was everything up to the verb. So in our given sentence here, we have the altitude to the side of a scalene triangle forms two congruent angles with that side of the triangle. All right, now think about your English class. Where's the predicate? Well, the verb is forms, so I'm going to split the sentence there. And that might make it a little easier to see that my givens are going to come from the subject. So I know that I'm dealing with an altitude to the side of a scalene triangle. That's going to be given. And what I'm going to have to prove is that that altitude forms two congruent angles with the side of the triangle that it's drawn to. Okay, once again, we have our givens and our proof statements over on the left, our diagram on the right, and we start off with the diagram. So I know I need to draw a scalene triangle and an altitude drawn to the side. So that's a scalene triangle. You'll recall that scalene just means that none of the sides are congruent. So long as I have a triangle ABC where none of the sides are congruent, I've satisfied that it's a scalene triangle. AD is going to be my altitude. So now I'm going to write out my givens in terms of the diagram. So triangle ABC is scalene and AD is an altitude. That restates what I was told in the subject portion of the sentence. The proof is going to come from the predicate. And that means that two congruent angles are going to be formed, those being ADB and ADC. All right, we'll save the proof until later. For this example, we're going to need a theorem that we're not going to pick up until the next section. But I hope that you see the three different types of proofs without diagrams. There's one where the given and proof are presented directly. There's the conditional type where the givens are in the if and what you have to prove is in the then. And then the trickiest of all is the declarative sentence where the givens are in the subject and what to prove comes after the verb in the predicate of the sentence. Okay, thanks for watching, and I hope this helps.